So 7, 7 today, we're going to still be factoring, but it's special cases, and we can still use the X method. Okay, and that's my suggestion, is that you keep on using that. But you're going to recall from section 7.3, when I gave you things like x plus 7 quantity squared, when we had to square a binomial, what did we do? We did what?
Create like a whole second equation.
Okay, so we said squaring something is just taking it times itself, and then we used FOIL, right? Mm-hmm. So we took first term times first term. We looked at the outside product and the inside product, and we noticed that they were the same, so it doubled. And then we took the last term times the last term. We called this, if you go back to your 7.3 notes, we called this a perfect square trinomial. It's a trinomial. It has 3 terms in it. And when you square something, you get a value that's a perfect square. 49 we call a perfect square because it's 7 squared. X to the second power is a perfect square because x is being squared. X to the first power is being squared. Okay, so this is a perfect square trinomial. Well, what you're going to do today is you're going to be factoring these perfect square trinomials. So, for example, I may give you x squared plus 8x plus 16 to factor. And you might recognize that it's a perfect square trinomial. The first term, x to the second power, is a perfect square. And any variable raised to an even power is a perfect square. X to the 4th power is a perfect square. X to the 8th power, x to the 6th power. If it's raised to an even power, it's perfect square. We're just going to work with x to the 2nd, however. And the number 16 is a perfect square. What value times itself gives me 16? 4. Okay, so if I know the pattern, I could factor this. I could just tell you what the answer is. But what I'm going to tell you is, let's just keep doing the x until we get the hang of this. Until we start to recognize patterns, we can still use the x method. What's the coefficient in this? 1. 1. So I'm taking 1 times 16. And I'm looking for a middle term of 8. So what factors of 16 are going to add up to 8?
4.
4 and 4.
Yes.
Notice they're the same. So we get x plus 4
squared
and x plus 4. And then using the x method, we can't forget, we have to divide by the 1. But when we divide by 1, does it change anything? No, because they always divide, right? So this is going to be x plus 4 times x plus 4, which you're welcome to leave your answer that way. Or because they're identical, we could say our answer is x plus 4 quantity squared. I don't require you to do that, but if you want to, you can.
It would be easier.
So some of what you factor today is going to end up being a quantity that's squared. X squared plus 6x plus 9. You might be able to right now tell me what the answer is. It is a perfect square trinomial. We got an even power up front here, and this is a perfect square. If you're not sure what it is, you can make an X. Take your first number times your last number. We're looking for factors of 9 that are going to add up to 6. 3 and 3. And again, they are the same. It's going to be x plus 3 and x plus 3. Or I can write that as x plus 3 quantity squared. The only thing that's changed from, if you're using the x method, the only thing that's changed is we're now expecting these to be the same. One more of those. You can have coefficients that aren't 1. Four x squared plus 12x plus 9.
It's a big oof.
Okay, it's a perfect square trinomial because the first coefficient 4 and the last digit 9, those are values that are perfect squares. Okay, values that are perfect squares would be like the number 1, because 1 squared is 1. 2 squared is 4, that's why 4 is a perfect square. This is just 2 squared. And 9 is a perfect square because 3 squared is 9. 4 squared is 16. 5 squared is 25. So these values are your perfect squares. If I make an x on this and I multiply 4 times 9, I would get 36. And my middle is 12. What factors of 36 are going to add up to 12?
6.
6 and
6.
6. So I'd say x plus 6 and x plus 6. Now I'm not finished. It's not x plus 6 quantity squared because that would not give me that trinomial. I have to divide by the leading coefficient. I'm going to divide these by 4.
Reduce.
And I have to reduce the fraction. This is going to become 3 over 2. Now I can slide 2x plus 3. I'm going to reduce 2x plus 3, and they're identical, so I could answer this by, I can leave it like this, or I can say 2x plus 3 quantity squared.
Yeah.
Okay? Want to see any more of those?
We're good.
You're good. Okay, that's one pattern, that's one special case. If you recall from 7.3, there was a second pattern, or a second case. Recall 7.3 again. I asked you to multiply x plus 3 times x minus 3. What if they weren't the same? It was their signs that were different. What did we get when we FOILed this?
There's a binomial.
We got a binomial, that's right. What was the first term in the binomial? It would be x squared. Okay, first term times first term still produces the x squared. But now the outside and the inside pieces would cancel out. And the last term times the last term was always negative.
9.
In this case, negative 9. X squared minus 9.
9.
We called this a difference of squares. Okay, again, it's a difference because it's always subtraction. And squares, again, we have perfect squares. 9 is a perfect square, x to the second is a perfect square. What you're going to do is you're going to be given the binomial and you're going to work backwards and factor it into the two binomial factors. So you might have x squared minus 64. It's a binomial. It's going to factor into two binomials. Anybody want to guess as to what those are?
8.
James?
Plus 8 and negative 8.
Okay, so I'd say x plus 8 and x minus 8, and he's correct. The signs are going to be different. That's why the middle term drops out here. And then last term times last term have opposite signs. That's why it's a negative 64. If you want to do the x, you can do that. When you multiply the first digit times the last digit, this is a 1 times a negative 64. So you're getting negative 64. But what about the middle term? in this example?
There is.
There is none. So what we would say for the coefficient is a 0. There's 0 x's.
How'd that work?
So what factors, so when I multiply, I get negative 64, but when I add, I get 0? That's where you'd say plus 8 and minus 8. And that's what goes in to your parentheses. So you can still use the x method with a binomial. It's just that middle term, that linear term, it isn't there. It's 0 for a coefficient. X squared minus 36. When we have to factor this, it's a difference of squares. I know it's going to factor into 2 binomials. Mackenzie, what do you think it's going to factor into?
X plus 6 and X minus 6.
You said x plus 6 and x minus 6. And again, it doesn't matter which one of these you put first. If you said x minus 6 first, then x plus 6, that's fine. If you're not sure, you can still make an x. And I can take the first digit times the last and say negative 36, but 0. So I'd be choosing a positive 6 and a negative 6. That still works. Okay, now your leading coefficient isn't always going to be a 1. It could be, like a 9x squared minus 100.
Oh boy.
Okay, you might recognize the pattern and be able to go right to the answer. Anybody want to take a guess at it?
No.
That?
Boy. Oh dear. It's not 10.
Noah?
9x plus 10 and 9x minus
Okay, if I did that, would first term times first term give me 9x squared?
No.
You did first term times first term? Would you get 9x squared?
10? Get 81.
You get 81. So what do I need to have here? 3.
Yeah.
There you go. Now, let's look at the x method. What happens when I do this? 9 times negative 100.
Negative 900.
Negative 900. And you're going to put 0 down here. What factors would I multiply and get negative 900, but when I add them up, I get 0?
That's confusing.
What are factors of 900?
Negative 30 and 30.
That's 90.
30 and 30?
30 and 30.
See,
So
that's
one
what
of
you
them,
just said.
negative 30, positive 30.
That's what you just said, though.
Yeah, that is what I said.
You didn't say 3 and 30?
You said 30 and 30.
Okay, so 30 and 30. So I would do x minus 30 and x plus 30. And then what do I have to divide by? I have to divide by my leading coefficient. Doesn't divide, but I have to reduce the fraction, right?
Dang.
So it's going to reduce down to 10 over 3. So we slide the 3 and leave the 10.